On this problem, there's a few different ways to approach it. I think the most straightforward way is to rewrite it algebraically as 13 times the quantity x squared plus 1 to the 1/7 power. Since the square root of x squared, the 7th root of x squared plus 1 is in the denominator, that means the sign of the power would be negative. So if you recall, the nth root of a can be written as a to the 1 over n. And if that is in the denominator, I can write that as 1 over a to the 1 over n. And then if I pull this whole thing up to the numerator, I make the power of the exponent negative, so a to the 1 over n. Essentially, that's what we did here. So then taking the derivative, we could do the power rule in combination with the chain rule. So I have 13 times minus 1/7 times x squared plus 1 to the minus 1/7 minus 1 times the derivative of the inside, which ends up being 2x. So cleaning this up a little bit, I have minus 26 over 7x times the quantity x squared plus 1, and then minus 8 over 7. Right? Minus 1 minus 7 gives me a minus 8 over 7. Cleaning this up, again, depending on how they want you to input it into MyMathLab, on an exam, this would be perfectly simplified at that point, would be fine. MyMathLab might want you to only have positive exponents, so you can write that as minus 26x over the quantity 7, or over 7 times the quantity x squared plus 1 to the 8 over 7, because again, since it's in the numerator negative, I drop it down to the denominator, it becomes positive. That would be perfectly fine. There are other ways to approach this problem. You could definitely do the product rule, right? If I have, let's say, if I have y equals f over g, the derivative of y would be the derivative of the top, hold the bottom, minus the derivative of the bottom, hold the top, all over the bottom squared. You're going to end up with the same answer. The notation might be a little different, but you should simplify and be able to come up with the same thing. If you have any questions on this, please let me know, and I can go through them.